I would like to introduce our next speaker. Professor Stephen Barr has his PhD in physics from Princeton University, and he teaches in the Department of Physics and Astronomy at the University of Delaware. I have seen his name pop up all over the place on these scientific questions about philosophy, theology, and science, and turns out he's a physicist who believes in God. Apparently in this room today, we have many people trained in science who also believe in God, and I want all of them to be stand. No, so it is wonderful that in this very diverse panel that we have someone whose primary training is in physics and can now address this super important question about creation and the Big Bang.
Thank you, Margarita. Can everyone hear me? Okay, I'm not too loud. Okay. Not only are there some scientists who believe in God, there are actually quite a lot of us. And I am the president of a recently formed organization, put a little plug here. Back in the summer of 2016, a group of us, about 6 of us, formed something called the Society of Catholic Scientists, and we're now up to almost 1,000 members. Now, if you have a PhD, if you are a practicing Catholic, because it's Society of Catholic Scientists, if you have a PhD in a natural science, and we include math and computer science, or are a grad student working towards a doctorate in one of those fields, or an undergraduate major, then you qualify. So just Google Catholic and scientists, and you'll find our organization, and it'll show you how to join. All right, now that the commercial is out of the way. So in this talk, I'm going to discuss a very large subject, the universe. Did it have a beginning? It's a large subject, but it's not the most important subject. A human person is more important than the whole astronomical universe, than a whole galaxy, unless, of course, there's a rational being living in that galaxy. Did the universe have a beginning? Will it have an end? And does it have any discernible purpose as far as science can tell? I'll discuss these questions both from the point of view of traditional Christian teaching and from the point of view of modern physics and cosmology. So naturally enough, I'll begin with the beginning. That is, I'll begin with a question of whether the universe actually had a beginning. We'll look first at what Christian doctrine says, and then at what philosophy and modern science have to say on the subject. For Christian doctrine, the fundamental text about the beginning of the universe, is the first verse in the Bible, Genesis 1:1. In the beginning, God created the heavens and the earth. This verse affirms both that the universe is created by God and that it had a beginning. It's quite important to recognize that these are two logically distinct ideas, even though they are tied together by this scriptural verse. Creation refers to the fact that the universe depends for its existence upon God, who is the source of its being. Beginning refers to the universe having a temporal starting point rather than having a history that stretches infinitely into the past or that goes around in a loop. The Catechism of the Catholic Church, in explaining Genesis 1:1, quite properly treats beginning and creation as distinct components of its meaning. In section 290, it says, 3 things are affirmed in these first words of Scripture. The eternal God gave a beginning to all things that exist outside of himself. He alone is creator, and the totality of what exists, expressed by the formula, the heavens and the earth, depends on the one who gives it being. Although being created and having a temporal beginning are distinct ideas, many theologians, philosophers, and ordinary people have seen them as connected in a necessary way. For example, the great 13th century Franciscan theologian St. Bonaventure, believed that each implies the other. The universe being created implies it has a temporal beginning, and the universe having a temporal beginning implies that it is created. On the other hand, his contemporary, St. Thomas Aquinas, disagreed, seeing the two notions as independent of each other. St. Thomas believed that God could have created a universe that was past infinite had he chosen to do so, but that as a matter of fact, God chose to create a universe that has a temporal beginning. In St. Thomas's view, we only know that the universe has a temporal beginning because God has chosen to reveal this fact to us, whereas the fact that the universe is created can be known even without divine revelation by the natural light of human reason and proved philosophically. Now, if we turn to the pagan philosophers of antiquity, of ancient Greece, including Aristotle and probably also Plato, we find that they believed neither in creation nor in a temporal beginning. Indeed, St. Augustine relates in his Confessions that some pagans of his day mocked these ideas by asking what the Jewish and Christian God was doing for all that infinite time that would have elapsed before he got around to creating heaven and earth. To this question, St. Augustine gave a profound answer in the 11th book of his Confessions. He pointed out that time is a measure of change and presupposes the existence of changeable things, which means created things. Therefore, time is a feature of the created world, and indeed, time itself is something created. From this, it follows that if time is passing, then something created already exists, and creation has already taken place. It's therefore nonsensical to speak of a time before creation. It is a contradiction in terms. So St. Augustine answered the pagan taunt in these words: "But if there was no time before heaven and earth, why do they ask what you, O Lord, did then? There was no then where there was no time." In other words, the beginning of the created world was also the beginning of time itself. While others had spoken of a beginning of time, it seems that St. Augustine was the first to understand and articulate this idea clearly. Modern physics came to the same concept 15 centuries later by a parallel route. St. Augustine had started with the insight that time is something created, whereas modern physics started with the insight, coming from Einstein's theory of general relativity, that time is something physical. If time, or space-time, is something physical, then the beginning of the physical universe must also be the beginning of time. Just as St. Augustine profoundly realized that it makes no sense to speak of a time before creation, modern physics says that it makes no sense to speak of a time before the physical universe began. So if, say, the universe began 13.8 billion years ago, then it would be meaningless to speak of a time of 20 billion years ago. There is no such time. That's a meaningless phrase. The notion of the beginning of time is now enshrined in Christian doctrine. Both the Fourth Lateran Council in 1215 and the First Vatican Council in 1870 taught that God created the universe ab initio temporis, from the beginning of time. St. Augustine's insights, let's see, I think I might have skipped a slide. Yes, there it is. St. Augustine's insights have an important corollary. God, in his divine nature, is atemporal or non-temporal. If time is something created by God, then temporal categories cannot apply to the divine nature. God dwells in an eternal, that is timeless, present. In St. Augustine's words, God dwells in the sublimity of an ever-present eternity. St. Thomas spoke of God dwelling in the nunc stans, the now that stands still. This, of course, fits well with the perspective afforded by us by modern physics. If space-time is the fabric of the physical world, as general relativity tells us, then the divine nature could not be temporal without also being spatial and physical, a notion that has always been rejected as absurd by Christian tradition. We've seen that Christian doctrine, based on divine revelation, arrived at the conclusion that the universe has a temporal beginning that is also the beginning of time itself. What can reason, unaided by divine revelation, say about the question? Some philosophers have claimed, contrary to St. Thomas, that it is demonstrable by reason alone that the universe had a temporal beginning. This is claimed, for example, by the proponents of the so-called Kalam argument for the existence of God, the most well-known proponent of which is perhaps the Christian philosopher and apologist William Lane Craig. The Kalam argument purports to show philosophically, A, that the universe must have had a temporal beginning, and B, any entity which has a temporal beginning must have a cause outside of itself. Several medieval scholastic philosophers also believed that the finite age of the universe can be proved philosophically. A notable example is St. Bonaventure. Whoops, there's a funny thing on the screen there. Am I supposed? Well, we'll see what happens when I push the button. Okay. I'm just putting up quotes there, so you don't actually have to look at the screen, because I'm just putting up the quotes that I'm saying aloud. So St. Bonaventure, for example, had several arguments, philosophical arguments, that the universe had to have a finite age. One was that if the universe were infinitely old, he said there would have been some particular past days that were infinitely remote from the present. But the day after such an infinitely remote day would also be infinitely remote, as would the day after that, as would all subsequent days by mathematical induction. And therefore, you could not go from that infinitely remote day to the present by the passage of time. The fallacy here is immediately recognizable by anyone familiar with modern mathematics. The past can have an infinite extent without any particular past time being infinitely remote. In the same way that the natural numbers, 1, 2, 3, 4, 5, 6, and so on, are an infinite sequence, but every particular natural number is finite. So his argument there is simply fallacious. Another argument he gave is that every day that passes is adding to the past. But if the past is infinite, that means you would be adding to infinity, and you can't add to infinity. So he thought. Again, that's mathematically a fallacy, and it's, I think, rather impressive that St. Thomas Aquinas saw through these fallacious arguments and showed that they were fallacious 6 centuries before modern mathematicians such as Bernard Bolzano and George Cantor clarified thinking about infinite quantities and infinite sets. In St. Thomas's view, it is not logically or philosophically impossible for a temporal sequence to proceed to infinity, either in the past or in the future. And most modern mathematicians and physicists would agree with him on this. And I should note that the argument to a first cause that was embraced by St. Thomas was not to a cause that is first in a temporal sequence, but one that is first in an explanatory sense, that is, to a metaphysically ultimate cause. So St. Thomas, as I said, thought that the universe could be, philosophically and logically speaking, it could be infinitely old, but we know by revelation that it isn't. Now, I think Thomas was correct that we cannot know mathematically and by reasoning mathematically and philosophically alone we cannot decide the question of whether the universe had a temporal beginning. What about empirical science? Well, until modern times, science was not in a position to say anything much on this question. But by the late 19th century, several discoveries had been made that seemed to bear upon it. And most of these discoveries seemed to go against the idea of a cosmic beginning. In Newtonian physics, for example, it seemed natural to assume that time extended infinitely into the past and into the future, just as space was thought to extend infinitely in all directions. In the middle of the 19th century, physicists discovered that energy is conserved. It cannot be created or destroyed, but only changed from one form to another. And chemists discovered that atoms are never created or destroyed in chemical reactions. So it began to appear that matter, energy, space, and time had always existed and always would. And so you see quotes from these, well, I'll read them anyway. The Nobel Prize-winning chemist Svante Arrhenius said in 1911, "The opinion that something can come from nothing is at variance with the present-day state of science, according to which matter is immutable." The Nobel Prize-winning physicist Walter Nernst declared that to deny the infinite duration of time would be to betray the very foundations of science. Okay. Now, of course, it was realized even back then that the Earth must have had a beginning, since the Earth's interior is still hot, and it would have cooled off by now if it had been infinitely old. And some scientists used the second law of thermodynamics, which I'll discuss later, to argue that the universe also must have had a beginning. But that was hard. It was hard at that time to make scientific sense of a cosmic beginning. And the view began to prevail among scientists, at least those who were not religious, that the universe had always existed. To many, the idea of a beginning came to seem like the relic of religious mythology and contrary to modern science. But thinking on the subject took a dramatic turn in the early 20th century. It started with Einstein's theory of gravity, called general relativity, which was published in 1916. In Einstein's theory, space and time form a four-dimensional manifold, which one can think of as a physical fabric that can bend and ripple in response to the matter and energy that fill it. In the 1920s, a Russian mathematician named Alexander Friedman and a theoretical physicist, Georges Lemaitre, who was also a Catholic priest, showed independently of each other that the equations of Einstein's theory of gravity could describe a universe that is expanding. That is not just a universe in which matter is moving apart, but a universe in which space itself is stretching to make the universe larger. Lemaitre was aware of astronomical observations that showed that distant galaxies are receding from us, and on the basis of these observations and his own theoretical calculations, he proposed that the universe is indeed expanding from an initial explosion, which he called the primeval atom, and which is now called the Big Bang. In the 1960s, cosmic radiation left over from that explosion was discovered by Arno Penzias and Robert W. Wilson, and since then, evidence for the Big Bang has accumulated rapidly. There's now no doubt among fundamental physicists and cosmologists that there was a Big Bang about 13.8 billion years ago. In the standard model of cosmology, the Big Bang is assumed to be the beginning of the universe and of matter, space, and time itself. That does not resolve the question definitively, however, as many speculative extensions of the standard model have been proposed, the standard model of cosmology have been proposed. And in some of these scenarios, they're not yet testable theories, the Big Bang was not the beginning of the universe, but rather one event in a universe that stretches back farther. Some of the more important speculative scenarios in which the universe had a pre-Big Bang history are called the bouncing universe, the ekpyrotic universe, and eternal inflation. In the bouncing universe scenario, the universe is supposed to be undergoing endless cycles of expansion and contraction, with each contracting phase ending in a bounce, which leads to a new expansion. The Big Bang would merely have been the latest such bounce. In the ekpyrotic universe scenario, our universe is one of two parallel universes that undergo endless cycles in which they crash into each other by moving through a fourth space dimension. So they would repeatedly crash into each other. The Big Bang would have been the latest such crash. In the eternal inflation scenario, bubble universes are constantly forming within a larger universe that is perpetually expanding. The Big Bang would have been the formation of our bubble. These scenarios are very interesting, and one of them might be correct. Nevertheless, there are strong theoretical reasons to think that even in such scenarios, the universe as a whole probably would have to have had a beginning, a temporal beginning. In a bouncing universe, there would probably have to be a first bounce. In an eternally inflating universe, there would probably have to be a first bubble. And in an ekpyrotic universe, there would probably have to be a first collision. There are two reasons to think this. The more fundamental reason is the second law of thermodynamics, which I've already alluded to. This law says that entropy, a mathematical measure of physical disorder, always increases, which causes physical systems to run down, wear out, or decay. This is what makes so-called perpetual motion machines impossible. It's also why we're mortal. The point is that a universe that has lasted for an infinite time would be, in essence, a perpetual motion machine. The second reason is a theorem proved in year 2003 by the physicists Arvind Borda, Alan Guth, and Alexander Vilenkin, which says, roughly speaking, that if one traces the history of an expanding universe backwards in time, one must come either to a beginning of time or to an era where classical concepts of time are no longer apply because of quantum mechanical effects. For these and other reasons, it's turned out to be difficult to construct reasonable and viable mathematical models of a past infinite universe. So even though we cannot be certain from the scientific evidence that the universe had a temporal beginning, it nevertheless seems most likely that it did, given everything we know at present. This can be seen as a vindication of Jewish and Christian revelation. The idea of a cosmic beginning was mocked by ancient pagans as absurd and rejected by many modern atheists as unscientific. Nevertheless, it now appears to be most probably correct. Now, one might ask why this is an important fact about the universe from a theological or philosophical point of view. Why does it matter? One answer is that a universe that moves from a beginning to an end is a story, and a story can have a point. By contrast, a cyclic universe in which history exactly repeats itself without beginning or end seems utterly futile and meaningless, like a hamster wheel. Even a universe that is not cyclic, if it has neither beginning nor end, is not going anywhere. This brings us to consider a very basic and yet still quite mysterious fact about our universe, namely that time has a direction or arrow. Things move from past to future. This fact sounds so simple as to be trivial, and yet it remains at this point unexplained by theoretical physics. It's connected to the second law of thermodynamics. Macroscopically speaking, processes always move in one direction towards greater overall entropy. We can therefore say that the reason that there is an arrow of time, a directionality to events in the universe, is that the entropy is connected with the fact that the entropy of the universe was astonishingly low at the time of the Big Bang. But why the entropy was so low at that point is not at present known. Whatever the ultimate physics reason for time having an arrow, it is certainly a fact about our universe that is of the utmost theological importance, as it would seem to be a precondition for the universe to contain responsible agents who can engage in meaningful activity. So that's all I have to say about the beginning of the universe. So now I want to talk about the creation of the universe. Many people, many religious people, see the presumed fact that the universe had a temporal beginning as proving that the universe was created. Some people refer to the Big Bang as the moment of creation. For their part, many atheists think that if the universe was shown to be past infinite, or in some other way not to have had a first moment, it would disprove the need for a creator. Stephen Hawking, for example. Now, both are making the same mistake of simply identifying a temporal beginning with creation. That these are distinct notions I already emphasized at the beginning of my talk, and I think some analogies will perhaps make this clearer. A piece of music has an internal sequence measured by beats or notes. The beginning of a symphony is the set of notes located first in that sequence, whereas the creation of the symphony is the conception of the entire symphony in the mind of the composer. The composer is not a part of the symphony, and his or her creative thoughts have no location in the sequence of the symphony's notes, though they are the cause of the notes and of their being organized in such a sequence. Similarly, a novel has an internal sequence of words. The beginning of the novel consists of the first words in that sequence, whereas the novel's creation takes place in the mind of the novelist. In other words, one can distinguish between the beginning or opening of something, which has to do with its internal sequential structure, and its origin in the sense of the ultimate cause of its existence. If someone were to ask why a certain novel exists, it would be silly to point to its first words. If somebody asked, why is there a novel, A Tale of Two Cities, it would be absurd to say, oh, because of it was the best of times and it was the worst of times. That's not the cause of the novel. That's the beginning of the novel. Rather, one would point to the author. Indeed, there could be a novel whose plot went around in a circle, and which was even printed on a scroll that looped around. It would have no first words, and yet it would have an author, presumably. In a similar way, if one asked why the universe exists, it would be silly to point to the Big Bang or whatever its first events were. Rather, one should point to the mind of the divine author. And even a universe that was cyclical and had no first events would still require such an author. Divine creation is the act by which God confers being upon the universe and all that it contains. As St. Thomas Aquinas put it, God is to all things the cause of being. God's creative act is the reason that the universe is a real universe, one that actually exists, rather than just a possible, hypothetical, or fictitious universe. Creation is the conferring of reality. It follows that God equally creates all things and events wherever and whenever they are located within the internal spatio-temporal structure of the universe. God is the source of being of this pen, right here and now. This is analogous to the fact that a composer is equally the source of every note of his or her symphony, and that a novelist is equally the source of every word of his or her play. God's creative act, therefore, is not something that happened once upon a time, a long time ago. Being an act of the divine mind, it has no location in space and time. It is a single, eternal, timeless act by which God wills the existence of the whole universe and all of its parts from its beginning to its end. God is therefore the creator of what is happening here and now, just as much as he is the creator of what happened 13.8 billion years ago. Admittedly, Genesis 1:1 speaks of God creating in the beginning, and theological tradition also distinguishes God's act of creating in the beginning from his act of conserving things in existence later. But theological tradition also says that this distinction is only verbal and notional, rather than real. According to Catholic theology, God's creating and his conserving are really one and the same eternal act. The foregoing is the traditional Christian understanding of divine creation. One sees from it that physics can have nothing to say about the creation of the universe, even though it may be able to tell us a lot about the physical events that happened at or near the temporal beginning of the universe. Some religious people have the notion that the events at the temporal beginning of the universe must have been miraculous in some way, in the sense that they cannot be described by science or that they are violated the laws of physics. This notion may be due in part to the fact that cosmologists often speak of the universe having an initial singularity. If one attempts to describe the evolution of the universe at its earliest moments using Einstein's theory of gravity, but ignoring quantum mechanics, one finds that there is a first moment of time at which various physical, call it t equals 0, at which various physical quantities must have been infinite, including the density of energy and the Riemannian curvature of space-time, and so on. Because of these mathematical infinities, the laws of physics would break down at that point. It is known, however, that it is invalid to ignore quantum mechanics when energy density and space-time curvature are as large as they must have been near the time of the Big Bang. Most fundamental physicists expect, for good physics reasons, that if quantum mechanics were properly taken into account in describing events near the Big Bang, the singularity would go away and the equations of physics would be found to apply at the beginning of the universe as well as everywhere else. I shouldn't say everywhere else because there are miracles. As far as theology goes, there's no reason to expect otherwise. Just as one would expect the first sentences of a novel to obey the same laws of grammar and syntax as all the later sentences, one would expect the events at the beginning of the universe to obey the same physical laws as the later events. It is absurd to suggest that if the laws of grammar apply at the beginning of a novel, it means the novel has no author. It would be equally absurd to suggest that if the laws of physics apply at the beginning of the universe, it means that the universe has no author. And yet, many atheists make exactly this argument, including the late Stephen Hawking toward the end of his life. He suggested that the full equations of physics may both require the universe to have a temporal beginning and also describe the physical events that occurred at that beginning, both of which ideas are perfectly reasonable, and I would say I believe them. But he went on to assert that this would render a creator superfluous. The answer to this is quite simple, and strangely enough, was given by Hawking himself many years earlier. In his 1988 bestseller, A Brief History of Time, Hawking noted that a theory of physics is, quote, just a set of rules and equations. And then he went on to ask, what is it that breathes fire into the equations and makes a universe for them to describe? The usual approach, this is still him talking, the usual approach of science of constructing a mathematical model cannot answer the question of why there should be a universe for the model to describe. This point can perhaps be made clear by another simple analogy. One may possess a book that contains the rules of baseball. Those rules describe the various kinds of things that can happen in a baseball game, in what sequence they happen, and so on, under what conditions they happen. They even describe how baseball games begin and how baseball games end. But those rules in no way can tell you whether any actual game of baseball is being played or has ever been played or ever will be played. The rules could be describing merely hypothetical or possible or fictitious games of baseball. A mere set of rules does not have the power to make real the events they describe. Just as the rules of baseball describe how a baseball game would begin, but do not cause there to be any real baseball games, so too the rules of a possible kind of universe, the mathematical equations that would describe a universe, that would govern a universe of that type, may describe how a universe of that type would begin, but they could not cause there to be a real universe of that type. The laws of physics have no power to create universes in the sense of giving reality to them. That's where the creator comes in. God, who is to all things the source of being. Now, does the cosmos, how much time do I have? 10 minutes? Okay, then I have two more sections. One is on whether the cosmos has a purpose or a point, and the other is how the universe ends. But since I won't have time, I'm not going to tell you how the universe is going to end. Come back next week and we'll tell you. I was going to describe the end of the universe. I'll send out the text and you can read from a theological and also from a scientific standpoint about the end of the universe. Does the cosmos have a purpose or a point, at least one that we can see through physics? An answer to that has long seemed reasonable and even obvious to many people. The point of the universe is primarily to manifest God's glory, but also to give rise to and be a habitat for beings such as ourselves. Human beings are, after all, the highest productions of nature that we know about. And yet, the discoveries of modern science have led some to conclude that humanity is a fluke. Bertrand Russell wrote that the human race is merely a curious accident in a backwater of the universe. And the Nobel Prize-winning physicist Steven Weinberg made this famous statement in his popular book, The First 3 Minutes, written in 1977. He wrote, it is almost irresistible for humans to believe that we have some special relation to the universe, that human life is not just a farcical outcome of a chain of accidents, but that we were somehow built in from the beginning. It is very hard for us to realize that we are just a tiny part of an overwhelmingly hostile universe. The more the universe seems comprehensible, the more it also seems pointless. Now, in the 40 years since Weinberg wrote that, much has been learned that undercuts his claim. In particular, it has been found that the laws of physics, as we know them, and the very structure of the cosmos, give every appearance of having been crafted to make complex organisms such as ourselves possible. Physicists have asked themselves how the universe would have turned out had the laws of physics been slightly different in various ways. For example, certain particles having slightly different mass or forces having slightly different strength. In many cases, what they find is that small changes in the basic laws would have had drastic effects that would have made the emergence of life as we know it impossible. Though this was once almost taboo to speak about among physicists, it is now quite widely admitted, even by scientists who are atheists. Stephen Hawking made no bones about it in his 2010 book, The Grand Design. Edward Witten, one of the top theoretical physicists alive today, most people in theoretical physics regard him as the smartest theoretical physicist alive of the last generation. Now, Ed Witten calls himself a skeptical agnostic. Maybe that's a polite term for atheist, but he calls himself a skeptical agnostic. But he said in an interview, there's really a feeling of wonder about the strangeness of the laws, because the laws of nature, to the extent that physicists have been able to unearth them, are extremely beautiful and harmonious, but also strange. And there's a second level of puzzlement about why these laws have such delicate properties. Just with physics, we already know that galaxies, stars, and planets roughly like ours could have formed, and that living things roughly like us could have formed, depends on many details of the laws of physics as we currently know them, being just the way they are and not being slightly different. I think we'll never resolve the sense of wonder about that. Such fortuitous features of the laws of physics are often called anthropic coincidences. There are many examples, some very famous. If the strong force that holds atomic nuclei together were about 20% weaker, a crucial nucleus called deuterium would be unstable, and as a consequence, almost none of the elements of the periodic table, except ordinary hydrogen, would have formed. And with only hydrogen, chemistry-based life would not be possible. If a certain energy level of the carbon-12 nucleus had been different by a few percent, larger or smaller, almost no carbon or elements heavier than carbon would exist. Again, with catastrophic consequences for the possibility of life. There's a parameter in the standard model of particle physics called the vacuum expectation value of the Higgs field, or V for short. In a widely cited paper I wrote with some colleagues back in 1998, we showed that V has to lie within a fantastically narrow range if life is to be possible in the universe. And we can give other examples. Nor is it just a question of certain parameters being precisely fine-tuned. Certain gross qualitative features of the laws of physics and of the structure of the universe are also vital, such as the fact that the number of macroscopic space dimensions is 3, that time has an arrow, which we discussed before, and that the universe obeys the very strange and highly non-trivial principles of quantum mechanics. Quantum mechanics is important in a number of ways for the possibility of life. The principles of quantum mechanics are responsible for the fact that matter comes in discrete units with stable and predictable properties, the periodic table, for example, out of which complex structures such as living things can form. The principles of quantum mechanics also arguably imply, this is controversial, that consciousness is not reducible to matter, to physics. And the indeterminism of physical law implied by the principles of quantum mechanics leaves a space in which the freedom of rational creatures such as ourselves can have scope for activity. It should be noted that there is a speculative hypothesis called the multiverse that could explain some and maybe most anthropic coincidences in a naturalistic way, especially the fine-tuning ones. The multiverse idea is that the fundamental laws of physics might allow certain quantities that were traditionally thought to be constants of nature, such as the masses of particles and the strengths of forces, to take different values in different parts of the universe that are very distant from each other. If enough values are tried out, as it were, there might be regions of the universe just by chance where all these quantities have just the right values for life to be possible. That's the multiverse idea in a nutshell. Now, the multiverse hypothesis is not far-fetched, as it may sound to non-particle physicists, but it is not far-fetched from a physics point of view, whatever you might think. But it would require that the fundamental laws of physics, because the multiverse, I should emphasize, in multiverse scenarios that physicists actually think about, the multiverse is a kind of universe. It's one universe. It's not many universes. It's one universe. And it has, most physicists would think, an ultimate set of fundamental laws that apply throughout the multiverse. But it would require that those fundamental laws of physics have the very special characteristic that they allow many important basic physical quantities to vary from place to place. In other words, I think one can say that for complex organic life to arise in a universe, it must be governed by fundamental laws that are special in some way, either in having many basic quantities and qualitative features chosen just right to make life possible, or in having the right characteristics to allow all these quantities and features to vary from place to place. The possibility that the universe might be a multiverse does not, therefore, vitiate the force of the argument that the existence of life is evidence of a cosmic purpose. The lesson would seem to be that the ability of the universe to generate beings, living beings, is not something to be taken for granted, as though it were to be expected of any universe, whatever its laws might be. Rather, as Witten said, it should arouse wonder. And this is the end of my talk. I think this is an important example. The size of the cosmos. Many have seen the vast scale of the cosmos, both in space and time, as evidence of the insignificance of human beings. If we are part of the purpose for which the universe was created, why so much empty space? As Weinberg pointed out in the passage quoted above, we are just a tiny part of the universe. Indeed, the same point was raised as a question by the psalmist. Oops. I left it out. I'll read it to you, though. When I look at the heavens, the work of your fingers, the moon and the stars that you have established, what are human beings that you are mindful of them, mortals that you care for them? Pascal wrote, the eternal silence of the infinite spaces frightens me. Interestingly, cosmology has something to say about this. We know that biological evolution requires billions of years to produce beings such as ourselves. And therefore biology, even before biology can start, the chemical elements required for life must be synthesized by astrophysical processes that also take billions of years. Moreover, Einstein's theory of gravity relates the longevity of a universe to its size. If one required that our universe never got larger than, say, a few thousand miles across, a comfortable human scale, then according to general relativity, it would last no more than a few hundredths of a second. Conversely, if the universe is to last for the billions of years required for life to arise, it must attain the vast size that we observe our universe to be. In other words, far from pointing to human insignificance, the vastness of the universe in both time and space is a necessary precondition for us to be here. To sum up what we've learned from modern physics and cosmology, the evidence strongly suggests that the universe had a temporal beginning, as Christians have always believed, on the basis of revelation. The universe will at some point end, that's the part I'm not telling you about, at least as a place habitable by life in any form, which also accords with Christian belief that this world will pass away. And finally, many features of the universe's laws and structure, including its astounding size and age, are just what is required for life such as ourselves to exist in it, which is suggestive that we are, as it were, built in from the beginning, to use Weinberg's words, and that there is a point to it all, and that we are part of that point. Thank you.